Okay, let's start section 7.2, which is using the law of cosines. And there are two cases that we're going to look at there, but first let's review the law of sines and where we use that. So with the law of sines, we have three different cases. We have angle, angle, side, angle, side, angle, and then the ambiguous case, side, side, angle. And you'll notice that in each of these cases you're given at least one angle and the side opposite that angle. And that's how we can apply the ratios for the law of sines. Well, what if you are given side, 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 which is all three sides? Well, we don't have a ratio that is complete, so we can't use the law of sines. Also, in the case of side, angle, side, when you're given two sides and the included angle, we can also not use the law of sines. So we need a law of cosines to help us out. And this is derived from the Pythagorean theorem. And if you want to take a look at your book on page 646, yep, 646, they describe that in a little bit more detail. But I'm just going to give you the three different forms of the law of cosines. So for any triangle ABC and corresponding sides A, B, and C, A squared is equal to B squared plus C squared minus 2 times B times C times the cosine of angle A. And you can see that side A is squared, and that's what this is equal to, and that we're taking the cosine of that angle that's opposite, so angle A. If we're trying to find information about side B or angle B, the formula is B squared is equal to A squared plus C squared minus 2AC times the cosine of angle B. And our third form, C squared is equal to A squared plus B squared minus 2AB times the cosine of angle C. So you can see the pattern that is set up in the formula, and it just depends on what information that you are given. So again, the side squared and the angle that we're taking the cosine of are going to be the same, and it's the other two sides that are squared then added together, and then you subtract 2 times those two side lengths times the cosine of the angle of the side opposite that you're given. So noting this relationship between the squared term, so what these are equal to A squared, B squared, A squared, or B squared, or C squared, and the indicated angle. So let's take a look at a quick example. So given two sides and an included angle, that's SAS. So we have a triangle here, we're given some information, let's just label that. So we have angle B is 98 degrees. Side A, which is opposite of angle A, is 13 feet. And side C is 20 feet. So again, you notice this is side, angle, side. The angle is included between the two sides. So we're going to use the law of cosines. And the side that we don't know is side B, so let's find that. So we're going to use the formula B squared is equal to A squared plus C squared minus 2AC times the cosine of angle B. And we'll substitute everything in. So we're going to have 13 squared plus 20 squared minus 2 times 13 times 20 times the cosine of 98 degrees. And again, make sure your calculator is in degree mode when you type this in. I'm going to show you the in-between steps, but you should be able to type this straight into your calculator and get the answer. The 13 squared is 169 plus 400 minus 2 times 13, oops, I didn't put that in yet. 2 times 13 times 20 times the cosine of 98 degrees. Since that's an obtuse angle, we're going to get a negative answer there. So we ended up with subtracting a negative 72.37. So we get 641.37, and then we have to take the square root to just get b. So we end up with 25.3 feet. And I just want you to notice, or take note, that angle B is obtuse. So we know when we find angle A and angle C that those are going to be acute angles. So again, angle B is obtuse, so that's going to be our largest angle, which should correspond to our largest side. A and C will be acute. Okay, let's see what else we can find. We still have two angles that are missing. So let's use the law of sines, because that's going to be easier right now than finding the angle with the law of cosines, but we'll get to that here in just a minute. So let's figure out our ratios. So we're going to have 13 over the sine of angle A is equal to 25.3 over the sine of 98 degrees. And that's also equal to 20 over the sine of angle C. Now we have two choices here. We can solve this for angle A or angle C, and then subtract both those angle measurements from 180 to get our third angle. So let's just find angle A. So if we cross multiply and then divide, we're going to get the sine of angle A is equal to 13 times the sine of 98 degrees divided by 25.3, and then we need to take the sine inverse of both sides to get A. So A is equal to the sine inverse of that ratio, which is 13 times the sine of 98 degrees divided by 25.3. And if you put that all in at once, make sure you put the parenthesis after the 98 degrees so it knows it's not taking the sine of the division by 25.3. And you type that in, and angle A is equal to 30.5 degrees. One more angle we need to find, that's angle C. So C is going to equal 180 minus angle A, which is 30.5, minus angle B, which is 98. So that gives us our answer of 51.5 degrees. And again, A and C are both acute. Fits with the relationships that we should have.